Hi, I'll go over how to do lab 9 of ECE 286, which is regarding bandpass and bandstop filters. So for experiment 1, you just have a simple RLC circuit with a 1K resistor, 100 nanofarad capacitor, and a 10 milliohm inductor all in series. And you're inputting a 5-volt source, and you're essentially measuring the frequency sweep across a combination of reactive elements. So you're just measuring the voltage drop from this node compared to ground. So the reactive elements. So I'll show you my setup. So that's not it. Give me a second. There we go. So this is my setup right here. So I have my 3K resistor. It's supposed to be a 1K, but I swapped it out with a 3K. Here's my 100 nanofarad, and then that's my inductor right there, all in series. And then my channel 1 is not connected, but when it does get connected, it will be measuring this applied voltage, and then channel 2 is measuring that combinational voltage drop across that inductor and capacitor. So you're supposed to do a frequency sweep in lab, but since we have an 82, like manually do a frequency sweep, you use measuring at certain frequencies. Since we have 82 and the M2K, you can easily do a frequency sweep. So I'm just going to go to Scopy and then go under my network analyzer. And then all I need to do is click, actually go to the gear, actually no, the 3 parallel lines, and just double check my channel 1 is my reference, and I'm inputting 5 volts peak. And that is, I believe that's 5 volts peak, because this is 10 volts peak to peak. So I'm just going to click single and let it run. Okay, so here's my result. And we want to measure at what frequency where the maximum voltage occurs for the resistor. But if you think about it, if we're measuring the voltage drop across the inductor and capacitor, this leftover voltage that's missing will only be attributed to the resistor. So that means this voltage, or sorry, the lowest point in the voltage is when the resistor has the highest voltage. So we could just measure this. If you don't believe me, you can easily just do a frequency sweep of this resistor by itself with a reference voltage measurement using either channel 1 or channel 2. In my case, I use channel 1. So channel 1 measured the input voltage, which is the 10 volts peak to peak, and then I'm using channel 2 as to measure the actual voltage that I'm concerned about. So now what I'll do is just, I will actually lower this point. So go, nope, parallel lines, and then change the minimum lower so that way I can see the minimum, and then add my cursor and then go and see what the lowest is. So mag 130. So yeah, that's the lowest. So at about 5.11 kilohertz, that's when the voltage of the capacitor, sorry, the voltage of the inductor is the highest. Not inductor, resistor. The voltage of the inductor is the, I swear, the voltage of the resistor is the highest because the voltage of the capacitor and inductor are the lowest. Cool. So that's how you do the experiment 1. Experiment 2, you're adding more of a reactive, you're adding more reactants. So you're substituting some resistors and you're substituting some inductors. So essentially the same thing. And you're still trying to determine at what frequency the voltage of the resistor is the highest. So I will not be going over that. It's the same thing. Same with experiment 3, but here you're specifically increasing inductance and increasing capacitance. And then you have this funky looking circuit where you're measuring the voltage drop between nodes A and B. So I will set that up right now. Okay, so I have my circuit set up. So it's pretty hard to see, but these are all 100 ohm resistors. You're supposed to use 1Ks, but I used 100, and then I'm still using the 100 nanofarad capacitor. And so this node right here, this row is my node A, and then this row right here is my node B. So A and B, I have it other way around. Give me a second to fix that. Okay, there we go. Now I write A and B. And then now I'm going to just perform a frequency sweep, and I'm going to have my channel 1 still reference my input voltage. So I'll just go to Scopy and then go ahead and click single, give it a moment to run. Okay, so this is what I got as my frequency sweep, and this is what it's supposed to happen. It's supposed to look like a horizontal line. So if you get something similar to that, you're fine. But that's essentially how you do lab 9 of ECE 286. Good luck.